This is lesson 3.2, solving two-step equations. With two-step equations, you need to perform two or more transformations. Transformations are changes to equations to solve the equation, right? You have to perform these transformations in the reverse order of operations. Remember our order of operations when you looked at things in grouping, same symbols, then with exponents, then with multiplication and division, addition and subtraction. Well, you have to perform these in reverse as transformations to undo those operations to get your equation back to its simplest form and solve for the variable. So we're going to perform subtraction and addition first, and then multiplication and division, and so on. Remember, your goal here is to isolate the variable. The variable should be all by itself, and normally it's by itself on the left-hand side of the equal sign, on the left-hand side of the equation. That's the normal convention. It's not that your answer will be wrong if it's flipped around, it just looks a little strange. So we're going to try to keep the variables on the left-hand side. In the first example, we have 1/3 x plus 6 equals -8. So the first thing we're going to do is undo that addition on the left-hand side. We want that x term to be by itself. So we're going to subtract 6 from both sides. That results in 1/3 x equals -14. But now we want to know what 1x equals. To do that, you have to undo this multiplication by a third, which is actually dividing by 3. Remember, division and multiplication are inverse properties. So to get rid of the 1/3, we're going to multiply both sides by 3. You can see by multiplying 1/3 by 3, that will become 1, and we'll have the x by itself, which is what we're going to try to do. But you have to do that on both sides of the equation. Remember, the equation always has to stay in balance, so what you do to one side has to be done to the other side. X then is equal to -42. So you're always applying the inverse operations to try to undo what is there. No matter what, you have to get the variable on one side of the equation all by itself. The next example shows how you have to combine like terms as one of the steps in solving two-step equations. So here we have 7x minus 3x minus 8 equals 24. Let's combine all those like terms on the left-hand side before we begin. That will be our first step. So we're going to add 7x and -3x. That becomes 4x. So you have 4x minus 8 equals 24. To isolate that 4x, you have to add 8 to both sides. We want that 8 to move to the other side, so add 8 to both sides of your equation. Becomes 4x equals 32. And then you divide by 4. When you divide by 4, you get x is 8. To check your answer, you can always substitute it into the original equation. And by original, I mean what was originally written either on the book, in the book, on the worksheet, on your test. Do not use your second or third step of your equation, just in case you've made a mistake in the transformations as you go. So we're going to substitute 8 back in there and make sure it works. When we do, we get 7 times x, that's 56. Minus 3 times 8, which is 24, minus 8, and does that equal 24? Yes, it does. So 8 is the correct answer to this equation. In the next one, we're going to try 2x plus 5 plus 8x plus 10 equals 75. Again, the first step is to combine all like terms, and this time, on the left-hand side, we have both variable terms that are alike and constants. So we're going to add our variable terms and get 10x because we have 2x and 8x. Remember, when you add variables, you add their coefficients. And then we're going to add 5 and 10. 5 and 10 is 15. So we end up with 10x plus 15 equals 75. But we want to solve for x. So we're going to subtract 15 from both sides. And we end up with 10x equals 60. To find out what x equals, we have to divide both sides by 10. So when we divide, we get x equals 6. So here you had several steps. You had combining the like terms, then we subtracted to remove the 15, and then we divided by 10. 3 steps to solve this equation. The conclusion here is that you must always combine the like terms before you start reversing the operations. It just makes things much more simple. Now we're going to find the input of an equation. To find the input of a function, it's just another way of saying finding the x value. Because remember, the x value is the input and the y value is the output. So don't be thrown by the change in vocabulary. When it says finding the input, it means find the x value. So here's the example. The problem is the output of a function is 3 less than 5 times the input. Find the input when the output is 17. So our strategy is first write this equation for the function. And we're going to look for keywords when we translate this. Whenever you look at a sentence, look for keywords. Whenever you see is equals. When it says 3 less than, that's minus 3. And 5 times the input means 5 times x. So when we rewrite this, we get y equals 5x minus 3. Now we're going to solve for the input when the output is 17. That's the original problem. So we're going to substitute the value for y. This becomes 17 equals 5x minus 3. We're going to add 3 to both sides. Remember, we want to isolate the x, so we won't want to have anything subtracted or added from its side. We're going to add 3 to both sides, and we get 20 equals 5x. But we want x by itself, so we're going to divide both sides by 5 to get 4 equals x. I rewrote that to read x equals 4. It's just convention to have the variable on the left-hand side. And then you can check your answer. You can also solve using the distributive property, but there are several steps here. You use the distributive property, so you multiply things out. Then you combine all your like terms. Then you move all your constants to one side, isolate the variable, and solve. So in our example, we have 5x plus 3 times the quantity x plus 4 equals 28. So we're going to use the distributive property like we did in the last chapter. It's 5x plus 3x plus 12 equals 28. We're going to combine all our like terms to get 8x plus 12 equals 28. Remove the constants from the left side, so we're going to subtract 12 from both sides to get 8x equals 16. And then we're going to divide by 8 to solve for x, so x equals 2. Whenever you see that the distributive property is involved, you should always do that operation first, and that will lead you on your way to combining the like terms, to removing the constants from the side, and then finally to figure out what the variable equals. So here's a word problem about a scuba diver. And it says, as a scuba diver descends into deeper water, the pressure of the water on the diver's body steadily increases. The pressure at the surface of the water is 2,117 pounds per square foot. That's pounds/foot squared. The pressure increases at a rate of 64 pounds per square foot for every foot that you descend. And you probably knew this intuitively anyway. If you ever dived into a deep end of a pool, the deeper you go, the more pressure you feel in your ears. Well, that's what they're talking about here. They want you to find the depth at which the diver experiences a pressure of 8,517 pounds per square foot. So think about the problem first. The pressure on a diver is the pressure at the surface plus the depth that he's going times the rate of increase in pressure per depth, right? So we're going to keep increasing the pressure as we go down. They told us the rate that the pressure increases, so if we know how many feet we're going down, it will tell us how much total pressure there is. So I rewrote this as an equation where P equals total pressure, and that is the 2,117 pounds per square inch that are on the surface, plus 64 pounds per square inch per every D, where D is the depth of the diver. So for every foot, we're going to multiply it by 64 and then add that to our original pressure. The thing is, in this problem though, they don't tell you how far he's diving. They want to know how far he has to dive to have 8,570 pounds per square foot of pressure on him. So that is our P. They gave us the P. So we're going to substitute that for the big P at the beginning and get 8517 equals 2,117 plus 64D. We're going to subtract the 2,117 from both sides to get 6,400 equals 64D. And then we want to solve for D. So we're going to divide both sides by 64. We get 100 equals D, or D equals 100. So what this is saying is, because the depth is 100 feet, at 100 feet, the diver is going to experience pressure of 8,517 pounds per foot squared.